All right, calculator section number 1. Michaela's planning an event in a 5,400 square foot room. If there should be at least 8 square feet per person, what is the maximum number of people? So some of you might be able to just see this, or you could kind of sketch it out. So I have a room with 5,400 square feet in there, and every person gets exactly 8. So this is just a division problem. You're going to do 5,400 divided by 8 square feet. Correct answer is B, 675. All right, moving on down, number 2. So it looks like we have a geometry problem here. All right, so the first thing we want to notice is that the figure is not drawn to scale. So angles that look bigger than other angles, it might not really be true. So in the figure, 3 lines intersect at point P. If x is 65 degrees, so we have 65 degrees there, and y is 75 degrees, so we'll put that right here. What is the value of z? So ultimately, we are looking for this angle right here. Well, one fact from geometry you need to know is that straight lines, the angles that form a straight line are 180. So right here, this half a circle needs to be 180. So far, we have 65 and 75, which is 140. So when you subtract that from the 180 that we need, it looks like we're 40 short. So this angle is 40. And now we can use another property called vertical angles, where when 2 straight lines cross, these opposite angles right here, or vertical angles, must be equal to each other. So correct answer for this one is C, 40 degrees. Moving on down, number 3. So we have an equation, 1/2 x minus 1/6 x equals 1. So we're just solving a basic equation. The tough part is there's fractions in here. So one way you can clear fractions, and that's what I'm going to do, I'm going to clear the fractions by multiplying by the LCD of the denominators, or the bottom numbers. So LCD is the least common denominator. So the number that 2 and 6 both can go into is 6. So I'm going to rewrite this equation, and I'm going to multiply 6 times the 1/2 x, that's a minus, subtract 6 times the 1/6 x equals 6 times the 1. And by multiplying by that 6, I clear all these out. So I end up with 6 times 1/2, that's 3x. 6 times 1/6, that's minus 1x. And 6 times 1 is 6. Now it's a pretty straightforward combine like terms. Divide both sides by 2. And we get a nice little answer here of x equals 3. Now another method you could have done, since this is the calculator section, you also could have just plugged in -4, tried those, and seen if it equaled 1. It's a little slower that way, but you could do it. All right, moving right on down, let's go to number 4. So this one I'm going to have to shrink down a little bit. Scatter plot problem here. The scatter plot above shows 8 data points in the XY plane. So these dots here, these are our data points. So there they are. And then this is the line that they're saying is like the best fit line for that. If each data point is shifted 3 units up, a new line is made. So like for instance, if I take this point and I move it 3 up, this point goes 3 up, this point 3 up, this point 3 up, this point goes 3 up, this point 3 up, and then 3 up, be roughly in there. So if those are our new dots, our new line should pretty much just be shifted 3 up. All right, so 3 up. So that means that how will the value of the y-intercept? So this was our y-intercept. All right, where our new y-intercept should be exactly 3 up. Looks like my line kind of missed it a little bit. So it definitely will increase. All right, let's move on down. Number 5. Lines L and K in the XY plane above are the equations in a system of equations. How many solutions does the system have? Well, the big idea here is that solutions are the number of times that the lines intersect. Okay, so the only possibilities are, just to kind of show you a little bit on this, you could have the exact same line on top of itself, which this system would be infinite solutions. All right, if you kind of have the same exact line right on top of itself. You also could have two lines that never touch each other. They're parallel. And when that happens, it's no solution. But normally, it happens like this one does, where there's one intersection point. So the correct answer here is 1. Number 6, Gerardo has 3 blue shirts and W white shirts in his closet. These are the only shirts that he has. If Gerardo selects a shirt at random, all right, so statistics problem here from his closet, which gives the probability. So remember, probability is basically the number of ways that something can be chosen out of the total possibilities. So the probability is going to be, well, the total shirts, so total goes down here on the bottom. So this is going to be our total that's in his closet. Well, he has 3 blue and W white. So we don't know how many white. So we have 3 plus the W. So that's all the shirts in his closet. And what is the chance that he's going to select a white shirt? Well, we don't know how many there are, but he's going to select W out of the 3 plus W shirts. So the correct answer here is A. Now, it might be easier for you if you're kind of confused by that W, just put your own number in and put in like 5 white shirts. So now you say, okay, what's the probability that he's going to pull out a white shirt? Well, he has a total of 8 shirts in his closet, 3 plus the 5. And what's the chance he's going to pull a white out? Well, 5 out of the 8 choices. So you could also put your own number in there to help you out a little bit. All right, number 7 here. Looks like we have a big function, kind of crazy looking equation, quadratic. The vertical height in meters of the upper arch of a bridge can be modeled by the function below. X is the horizontal distance along the roadway from the entry to the bridge. All right, so assume this is the entry that they say. Let's kind of get that out of here. And it says the graph of y-axis is shown below. In the graph, the point 0, 0 represents the entry. So that's the point that we had kind of right down here. And which of the following represents the exit? Well, if this is the entry, the exit is on the complete opposite side. So that ordered pair right there is x is 500, y is 0. So I guess we'll have to go with D. Now be careful. If you put B, you just accidentally mixed up your numbers, which would be a point, way up in here somewhere. All right, number 8. The graph of f of x is a line in the xy plane, passes through the point 0, 2, has a slope of 5. Which of the equations could define this function? So basically, they give me everything I need. A slope of 5. So remember, y equals mx plus b. This m represents the slope. So I need a 5 there. And basically, that wipes out everybody except for this one. You also could use the fact that 0, 2 is the y-intercept. So that's another key feature of the graph that we could have used. And y-intercept of 2, that's this back number. And so that one would have eliminated a couple of them. You'd have still had this one that could have worked, but had the wrong slope. The correct answer there is D. Number 9, have a scatter plot again. Scatter plot shows citrus production in millions of tons. So just kind of be aware. That's a little something that they do sometimes. So like this number, for instance, right here would represent 18 million. Which of the following could be the slope of the line of best fit? So remember, slope is the rate of change, and it is the change in y values over the change in x. Formally, it's y2 minus y1, x2 minus x1. or some people even like to call it the rise over the run. So if my line is, let's just say that my line goes through right here, kind of right through those points. I'm going to pick 2 of those points to try to figure out my slope. So maybe I pick these 2 right here. So one point is at 0, 18 roughly. The other point looks like it is at 8, 35. So my slope, my vertical change, goes from 18 up to 35. So basically I'm subtracting these y values. And that looks like a vertical change of 17. So there's my change in y. My change in x is from 0 to 8. So from 8 to 0, that's my change in x. So up 17 over 8 is about 2 1/8 is 2.125-ish. So correct answer here is A. Number 10, they give me a function, and this type of problem is on almost all of these SATs. But they give me a function, and they write it out as factors. So this is in factor form. And what's really nice about factor form is I could multiply all of those out to find out what the exact equation is. I could do FOIL a couple times. But with factor form, it allows me to find zeros really easy, the zeros of the function. And the zeros of the functions, that is the x-intercept. A 0 is an x-intercept. So basically, let's figure out where these guys are zeros. So set this one equal to 0. And I get x equals -4. If I set the next one equal to 0, I get x equals 1. And if I set this one equal to 0, I get a fraction here, divide by 2, divide by 2, and I get x equals 3/2. So those are my x-intercepts for this function. And it says which of the following is not an x-intercept. So -4 is 0. That one's good, so I can't count it. -2/3 0. I didn't get that as one of my answers. 1 0 was right here. 3/2 0 is right there. So the one that is not an x-intercept, correct answer, B. All right, we have one of those multiple part problems. Looks like we have a table function. So the length CT, so this is the length of a channel catfish in the Iowa River T years after the first year of life. So basically when T is 1, that means it's 1 year old. Can be approximated by a linear function. Some values of C are given in the table above. And so then we have the actual function right there that says it could be the length f of t in inches of a flathead catfish. So this is a different catfish. In the same Iowa River T years after the first year of life can be approximated by F. So C is for channel catfish, F is for flathead. So number 11, according to the model, which of the following is closest to the expected age to the nearest whole year of a flathead catfish that is 31 inches long? So don't use the chart. We want to use the F function because that's for flathead. So, and F of t represents the length. So I'm going to plug 31 in for that length. I'm going to solve for it. So 31 inches, this should be able to calculate the years. So -4 minus 4, and we get 3t is 27. And when I divide by 2, or divide by 3, I mean, I'll get t equals 9. Now remember though, t is t years after the first year. So we need to add 1 for that first year, which gives us a correct answer of A, which is 10 years old. All right, number 12. So this is the second part of this problem. Says, which of the following equations could define C as a function of t? So basically, we need to find the equation for this chart over here. So a couple things, since it's linear. You can kind of think of this as the x and this is the y, the input and the output. And remember slope. Slope is always the change in y over the change in x. So whenever you're given a table, just look and see what the y is changing by, and it looks like we are growing by 2.5 on every single interval. So I know that that's going to be my slope because x is going by 1. So when I put change in y over the change in x, I end up with a slope of 2.5, which that wipes out d and that wipes out b. Now what we need for the back numbers are going to be decided by the y-intercept. Well, remember, the y-intercept occurs when t equals 0 or when x equals 0. So kind of run the pattern backwards and go back 2.5, and you will get an answer of 6. So that wipes out C. Correct answer is A. Number 13 and 14. This problem's going to be kind of tough to see if you don't have the actual sheet right in front of you, because it's kind of hard to smush all this on one page. But basically it says the results of a survey, contacts, lens fittings are summarized. The table shows the total number of fillings and the average age, mean is average, of patients who were fitted. The total fittings consisted of new fittings and refittings. So the two categories we're trying to kind of keep track of here are the new fits and the, how do they word this? New contact lens fittings and refittings. And that's kind of how you read this chart over here, where the refittings are the dark value and the new fittings are the lighter value, and together they should add to 100%. So number 13 says, what is the range? So remember, range is pretty much just the high minus the low value. So what is the range in years of the mean or the average ages of patients surveyed who had contact lens fittings in the country shown? All right, well, the highest value in this range is 36.3. And the lowest value over there is 26.6. So when I subtract those from each other, I end up with 9.7 is the difference between the high and the low. So that's just kind of a vocabulary problem. Number 14, which best approximates the number of patients surveyed who received refittings in New Zealand? So refittings in New Zealand. So I'm going to come over here to the New Zealand chart. Refittings are in black. So it looks like in black it's about 60 and a little bit. You know, that to me looks somewhere maybe around 62%, because this bottom portion, you know, for the new fittings, looks like maybe it's like 38, I'm kind of guessing. All right, but we want the 62%. So it says, what is the number of patients surveyed? Well, we got to see how many there was. So in New Zealand, it looks like there was 721. So out of the 721, what is the 62% of 721 that we're doing the refittings? And the shortcut for that percentage is you just change the percent to a decimal, divide by 100 or move it to the left. You multiply it by the total, and let me just punch this in. 0.62 times 721. So I'm getting about 447.02. So it looks like the correct answer there is C. All right, number 15, the park ranger asked a random sample of visitors. So it looks like we have a stats problem here. How far they hiked during their visit. Based on the responses, the estimated mean, or that's otherwise known as the average. Get my cursor going right here. So the average was 4.5 with a margin of error of 0.5. So what that means is, you know, if we have an average of 4.5, and then our margin of error means we could go plus 0.5 this direction or minus 0.5 in this direction. So we're looking at somewhere between 4.0 and 5.0. So that's kind of where the average lies. So which of the following is the best conclusion? It is likely that all visitors, that's a problem there, hike between 4 and 5. Not necessarily. You know, one person could have hiked 20, the other could have hiked 1, but the average, so that one's not in there. It's likely that most visitors hiked exactly 4.5. That's not it. It is not possible that any visitor hike less than 3. That's definitely not it. So all those keywords there, all, exactly, not possible. Those are words you kind of want to watch out for. Part D says that it is plausible or likely that the average distance hiked for all is between 4 and 5. That's the correct answer, D. Number 16, looks like we have like a little two-way table here, so a stats type of problem. Observe matings among fruit flies. So we have males kind of on this side going across. We have females coming down. Looks like whether they were raised on starch or maltose, so the two different variables. So the table above shows the observed mating frequencies among a group of fruit flies. What fraction of, so this is really important, whatever comes after the word of is going to be our bottom number. So what fraction of the observed matings? So of the observed matings, well, there was a total of 59 matings. So out of all the matings, how many were between fruit flies that were raised on the same medium? So the same medium would be like both raised on starch. So that box represents the same medium. But then on maltose, these are the males and females that both were on maltose. So we need to add those together. So it looks like 42 out of the 59 were raised on the same medium. So the correct answer. All right, number 17. Looks like we have a story problem with a graph. Figure above shows a graph of 6 regions, temperature and humidity conditions are going to result in different snow crystal shapes. Based on the graph, which of the following is a combination of temperature and humidity that will be formed? So they're giving us temperature and humidity, and we need prisms to be formed. So prisms represent this area right here. So we're looking for an XY combination. Remember, temperature's here, humidity's over there. So the first one says 5 and 0.15. Well, a temperature of 5 and 0.15 would put me probably right up in this area, which would be stars and plates, so that's out. 15 degrees Fahrenheit is right in this area. 0.18, which would be a little bit too high, that would be in the needles and columns. 20 degrees and 0.02, so that's going to be somewhere right around here, 0.02. So that one looks pretty good. Let's just double check D. D is 30 degrees and 0.08, which would be right up in here, which would be 6 pointed stars. So that one's out. So the correct answer, C. Number 18 looks like a stats problem. A sample of 40 fourth grade students was selected at random from a school. The 40 students completed a survey about the morning announcements. 32 thought they were helpful. So we have a sample of fourth graders. 32 out of 40 said that it was helpful. Which of the following is the largest population to which the results can be applied? Well, we should be able to apply it more than just the 40 students who were surveyed. All fourth grade students at the school. That one's looking pretty good. Let me just double check the others. All students at the school. No, because we can only look at fourth graders. The survey didn't do third grade or fifth grade. All fourth grade students in the county. There's a problem there because, you know, that school may have students that happen to like the announcements, and another school, maybe they're doing crappy announcements. So you can only apply the survey to the actual population that you're drawing from. So the correct answer there is B. All right, we have another multi-step problem here, different numbers. So the next two questions operate off the same chart. Ryan's comparing different hay balers. They have a width and a diameter. They got prices down below. Of the following, which ratio is, so a ratio, remember, is either, you know, a dot, dot, or a fraction. Which ratio is closest to the width of the bales made by A to D? So we need A to D, or A dot dot D, or A over D. Remember, the order that they say that, A to D, tells you who's on top and who's on bottom. Don't worry about who's bigger or smaller. Go in order that it's written. So the width of A is 46 inches. And the width of D, that's A, D is 62 inches. So when I look at that ratio, I think I divide that out, it's going to be less than 1. So the correct answer here is going to be A, 0.74 to 1. Now, if you messed up and if you picked B, which I've had a couple students do, they thought that you just automatically do the big over the little. So they accidentally did 62 over 46. But that's wrong because it didn't say D to A, it said A to D. All right, second part of this question, number 20. Which of the following is closest to the percent? So we got another little stats or percent problem here. By which the price of baler E exceeds C. So basically they want to know how much more is A than C. I think that was A. No, E than C. So basically we got to look at E is 46,900. And C is 32,000. All right, we need to see what the difference is, how much more it is, but then we need the percent. How much is E more than C? So C is going to be my bottom number. This is going to be my bottom part. All right, so we do that. Breaking out a little bit of math here. We got 46, so that's about 14,900 divided by 32,000. Check this out. 14,900 divided by 32. And it's about 46%. So correct answer here is D. You're going to get like 0.46, blah, blah, blah. All right, number 21. Looks like we have a system of equations, but this one's a little bit weird because you have this quadratic term in here, this x squared. So I imagine we're going to be factoring, but actually looking at the answers, to me these answers looks like we're going to need to use the quadratic formula. So just make sure that you have that memorized. It's not given to you. So really quick, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And I will explain that here in a second once we get through the system. All right, well, the first thing I could do is I noticed that this top part, I'm going to try to substitute here. So on this top piece, actually I could use elimination too if I wanted to. Let's try elimination right now. If I add up these two rows, all right, I get x plus x, which would be 2x. Negative y plus positive y cancels out. It eliminates. Then I get 1 plus x squared, and then a minus 3. So when I kind of clean all of that up, I get 2x equals negative 2 plus x squared. So I'm trying to solve a quadratic. And whenever you want to solve a quadratic, the first thing you need to do is set it equal to 0. So again, I knew it was a quadratic because my biggest term is an x squared. So there's no way to get x by itself like in normal linear algebra. So I'm going to set it equal to 0. And I'm going to minus this 2x from both sides. And I get 0 equals, and then writing this in descending form, positive x squared, negative 2x, minus 2. Now usually, I would try to factor this. And I would say, okay, let's find two numbers that multiply to make negative 2, but then they have to add to make negative 2. And I don't think I can do that because the only way to make negative 2 by multiplying is either negative 1 times positive 2 or positive 1 times negative 2, and neither of those add up to what they're supposed to. So that kind of tells me, uh-oh, factoring is not going to work. I'm going to need to use a quadratic formula. So in general, the term in front of this x squared represents the a. So since there's nothing there, there's actually a 1. So a is 1. B is the coefficient of the number in front of x, which is a -2. And c is the constant here at the end, which is -2. So now I have my a, b, and c. I'm going to go in and I'm going to plug them into the quadratic formula up here. So I have -b, be careful, that's a double negative, plus or minus the square root of b squared. When you do that in your calculator, hopefully you don't need your calculator, but if you do, put parentheses around it, minus 4 times a times c, all right, all over 2 times 1, which is 2. I guess I'll put that just to show it. Now we got to clean that up, so we have a positive 2 plus or minus the square root of, well, here we have 4. -4 times 1 times -2, that's a positive 8, all over 2. And going a step further, 2 plus or minus radical 12, all over 2. Radical 12 can be simplified. I don't really have time in this particular problem to show you how to simplify all radicals, but basically I can break that square root of 12 up into the square root of 4 times the square root of 3, which the square root of 4 is a perfect square. So it can be reduced to 2 radical 3. So 2 plus or minus 2 radical 3, all divided by 2. And when you have the whole thing divided by 2, what you can do is you can divide each piece separately. So I'm going to divide this side by 2, this side by 2, and I get 1 plus or minus the square root of 3. So that was my x value. Well, when I look at the answers, there's only one of them that has that, and that's right here. That's A. Now, I'm not going to go through all the legwork, but if you plug that back in, you would find out that y equals radical 3. Now, the only other option here would be to just start plugging in, all of these x comma y's and find the one that works. That would be very tedious, although luckily on this one, if you would have tried A first, you would have got your answer right out of the gate. Some people, another way to get started would be, instead of using elimination, some people may have chose to use substitution right here. So for instance, if you add this y to the other side and take away the 1, you would get x take away 1 equals y. And then you could substitute that in place down here in the bottom and have x plus x minus 1 equals x squared minus 3. And all it is, it's the same exact thing that we ended up with elimination. When you set it equal to 0, you minus the 2x to both sides. You add this 1 to both sides. And it's just another way to get to where I did with elimination. So I thought I'd show that. Number 22, it's like we have the graph of exponential function. So remember, exponential function starts slow and then grows fast, unless it's decay, and then it starts losing fast and then kind of tapers off. So that's exponential. Passes through the points. They give me some points here, so let's kind of just sketch this out. And at 0, 1, and 2, so they give me 0, and they give me 1, and they give me 2. And then my y values go from 1 to 4 to 16. So we'll jump up here to 16, maybe cut it in half a couple times. And so let's put these dots on the graph. 0, 1 is roughly right here. 1, 4 would be there. 2, 16 would be here. So we have this curve, going up like that. And it says which of the following is not true. So be careful right there with the word not. So a line could be drawn that does not intersect G. Well, that's true. All right. So I could draw a line, somewhere way over here. So this is example A. That doesn't intersect. So that can't be that one. A line can be drawn that intersects the graph at exactly 1 point. Well, yeah. If I draw a tangent line, it just nicks it right at 1 point, maybe right there. So there's an example. I can do that. A line can be drawn that intersects it at 2 points. That can happen as well. I can have a line comes down and kind of cuts through at two different spots. So there's an example of that. A line can be drawn that intersects at exactly 3 points. That is impossible. So the correct answer here is D. There is no way to draw a line that intersects that curve at 3 points unless it changes direction. Number 23, in a right triangle, the tangent of one of the two acute angles, acute means less than 90, is radical 3 over 3. What is the tangent of the other acute angle? So this is a trig problem. So first off, let me sketch a little right triangle here. So I have my right triangle, and I don't know what the degrees are, but I do know that they add up to 90, which isn't super important here. So let me just first call, I don't know, I'll call this angle theta and this angle alpha. You could use x and y, it really doesn't matter. You could even put some numbers in there just for pretend. But tangent, so there's something called SOHCAHTOA, and if you go back and watch one of my kind of content videos, I can explain this a little bit deeper. But TOA represents tangent. So this is the mnemonic device to remember what tangent is. And the tangent of some angle, let's say theta, is the opposite leg over the adjacent leg. All right? So that's kind of where the T and the O and the A come from for TOA. So tangent of theta means if I'm standing here, my point of view is from that angle, the opposite leg goes on top. So the opposite leg would be radical 3. You know, so all I'm doing is I'm going opposite across to the far side. You're opposite. And then the adjacent leg is the leg that's right next to me. So that's this leg. And that would be the bottom number here. So the bottom number is 3. That's the A. So this is 3. And if I needed to, I could get the hypotenuse, but I don't need to, but I could use the Pythagorean theorem. But it says, what is the tangent of the other acute angle? So what they want to know is, they want to know what is the tangent ratio of the other angle. So they want me to stand up here and do the tangent for that angle. Well, the tangent when standing on alpha is opposite over adjacent, because now it changes. Now when you're standing here, this would be the opposite side, and this would be the adjacent side. So it all depends on your point of view. So the correct answer here is D. Number 24, in the xy plane, line L has a slope of 2. K is perpendicular to L. Which of the following could it be an equation of K? All right, so just a couple quick facts here. A slope of 2 means that a line goes up 2 units over 1. Up 2 units over 1. So this line right here, going up 2 over 1, that line has a slope of 2. So we're going to call it line L. Now, if I want to be perpendicular, you know, that's the first word you need to understand. That means 90 degrees. So if I want to hit this line at 90 degrees, I need to be coming this way. All right? And that'll give me a 90-degree angle. Well, to make two lines be perpendicular like that, the big thing is you need to be opposite reciprocals. Okay? So the slopes need to be opposite reciprocals, meaning that this slope is going to be negative, and it's going to drop down 1 over 2. Okay? Down 1 over 2. So that's how you make two lines that are perpendicular to each other. So let's just kind of do it like this. Line L has a slope of 2, which it might be helpful to put it over 1, just to make it easier to do a reciprocal. And then my new line, line K, needs to have a slope of, here's the reciprocal, and here's the opposite. So basically I'm trying to find out which of these equations have a slope of -2. Now, the tricky thing is these are not written in slope-intercept form. They're written in standard form. So in general, let me just kind of break this down for you. This is standard form in general. And to get it solved for slope-intercept form, so I'm trying to go from standard to slope-intercept. where the y equals mx plus b. I want it like that. So what I need to do is my first step is I need to subtract the x term from both sides. All right. So that's negative ax plus c. And then I need to divide everybody by b. And I will now have it in y equals mx plus b form. Well, notice what the m is. The m, or the slope, is just the negative of a over b. So that's a nice shortcut to use. So going through these choices here, a is in front of x, b is in front of y, I can very quickly find all their slopes. So negative of a over b, all right, negative of a over b, negative of a over b, and negative a over b. And when I go through and I break all those down, you know, this top one would have a slope of negative 2, which doesn't work. This one would have a slope of 1/2, doesn't work. This one would have a slope of positive 2. That would be parallel because they're the same. And this is the one I'm looking for. That was the slope that we needed for K. So the correct answer here is D. Number 25, we have a geometry problem here. Diagram represents concept of space surrounding a person. Let's get into the dimensions here. So we have a bunch of dimensions at the bottom. Ultimate question, I'm kind of just going to cheat and go down to here. What is the area of the shaded region? All right. So basically the area of the shaded region is going to be this whole circle. Okay, but that's too much. So we're going to find out what the area of the shaded piece is. But that's going to be too much because we don't want this little piece. So we need to take away the area of the center. All right, and it looks like there's two circles there, so we need to get some numbers. Well, I'm going to kind of just come over here to the side. I'm going to kind of redraw what's important. So this is going to, I'm kind of ignoring all this crap out here because it really doesn't matter. So maybe I'll make that in blue. So we have this kind of blue circle here. And then we have the two circles in the center. And I'm going to make them a little bit bigger just so I can get some numbers on there. So let's try to figure out some values and what's going on. So it says intimate space, the very first one, has a radius of 1. So from the center out, that's 1. Personal space is a circle of radius 4 outside of intimate. So when you get all the way out to here, that's 4 from the center. So that looks like that's our red circle there. So this red circle has a radius of 4. So why don't right now we just get right after that. The area of a circle, remember, definitely need to know this, but it's on your front reference page if you forget. So area of a circle is pi times 4 squared. So basically I've just found this area. And now we got to figure out what is the radius of the blue circle. Well, the blue circle is social space. Social space has a radius of 12. So social space, boom, is a radius of 12. So that's the blue circle, pi 12 squared. All right, so we do the shaded area minus the center area that's white that we don't want. And that shakes out to be 144 pi. Take away 16 pi. And I can kind of treat pi as a variable and just subtract these coefficients. So that'd be what, 124, 128 pi. So correct answer there is B. Number 26, Anita created a batch of green paint by mixing 2 blue with 3 yellow. She wants to mix a second batch using the same ratio of blue and yellow. And she uses 5 blue, so how much yellow should she use? So this kind of looks like a classic proportion problem. And all proportions can be set up as 2 fractions equal to each other. And it says she did 2 blue to 3 yellow. So 2 to 3. And this was blue to yellow. So that was the first batch. So this is batch number 1. And then in the new batch, in batch number 2, it says she uses 5 blue. So I need to put blue on top. So we need to figure out how much yellow. Y is kind of our variable. Well, to solve these, you can always cross multiply. So I'm going to do 2 times y, 3 times 5, and divide both sides by 2. So we need to use 7.5 of the yellow. Well, I'm looking through here, exactly 5 ounces. No, it's supposed to be 7.5. 3 ounces more than yellow in the first batch. So yellow in the first batch was 3. So 3 ounces more. Well, that would equal 6, and that's not right. So you're not it. 1.5 times the yellow in the first batch. Well, yellow in the first batch was 3 times 1.5. Well, that's only 4.5. Nope, we need 7.5. So ain't you. 1.5 times the blue in the second batch. So there's blue in the second batch. 1.5 times that, and that's where we find our answer. Correct answer, D. All right, number 27. Looks like we have a linear equation. It says in the equation above, A is a constant or just some number. What is the value of A that makes the equation have infinitely many solutions? So to get infinite solutions, basically what happens is you end up with the same expression on both sides. So let's say you have something like 2 times x plus 5, and then you have 2x plus 10. Well, if you try to solve that, you're going to end up with this, and then when you start minusing your 2 x's from both sides, all your x's disappear, and you end up with this true statement that says 10 equals 10, or if you subtract 10 from both sides, you'll actually get it down to 0 equals 0. So that's a scenario where you have infinite solutions. Now, the flip side of that is if you have this equation, x plus 1 equals x. If you try to solve that equation and you minus x from both sides, you end up with 1 equals 0, which is false, and that's somewhere where you have no solution. So those are kind of what I call the freak cases, infinite solution or no solution, but basically your variables disappear. So let's kind of look at this one and work through it. I'm first just going to distribute this negative 4. So I'm going to have ax minus 12 minus 8x equals negative 12. Let's add 12 to both sides. Don't have to do this first, but I'm going to. And I get ax minus 8x equals 0. And let's add this 8x to both sides. It might be easiest to see what's going on here. And I get that. And so for these two sides to be the exact same, it looks like a has to equal 8. So if a equals 8, I end up with 8x equals itself, which would give me infinite solutions. So the correct answer here is D. All right, number 28 says the wholesale price of a kilogram of lentils decreased by 1% for 6 months. So we decreased by a percentage, all right, for 6 months. If X is the number of months, so that's what X is months, and the price began to drop, and Y is the cost, which of the following could model the cost over that time period? So basically, whenever you are decreasing by a percent, all right, so if we decrease by a percent, that is not linear, all right, that's exponential, because you're decreasing by a percent of a different number every single month because you're getting smaller and smaller. So in general, you want to do the starting amount, okay, multiplied by 1 minus the percentage, all right, and that's going to equal the price of where you're at, and then you got to put the time up here, however many times that happens. So if I want to do this problem, basically if I do a 1% drop, that's 1 minus 0.01. All right. So I know right now in my parentheses, I need a 0.99 to, and I guess I shouldn't use t here because it says x is the time, x is the number of months. So I know that has to be in my equation. So that wipes out, these are linear. Can't be linear because you're decreasing by a percentage each month. So now I'm down to these two, and I know the correct answer is C because this is a drop of 1% each month, all right? Where this is 1 plus 0.01, so this would be growth of 1% every month. So if you put 1 in there, you remain the same. If you're less than 1, you start decreasing. 1.65, that just must be whatever the starting price was, but they didn't ask about that. So the correct answer here is C. All right, number 29. This one's a little bit challenging. The equation above is true for all x that are larger than 2, where r and t are positive constants or numbers. What is the value of RT? So ultimately, we need to figure out what R is, what T is, and multiply them together. Now, I notice that they're trying to add two fractions here to each other with different denominators. So let's just kind of pretend. Let's pretend that you were trying to do 2/3 plus 3/4. All right, let's just say we were trying to do that. Well, if you were trying to add 2/3 plus 3/4, you need to get a common denominator. And one way to do that would be to multiply each fraction by the other person's denominator. So for instance, if I multiply 2/3 by 4/4, okay, this number, that doesn't hurt anything because I'm just multiplying by 1. And then if I multiply this fraction by 3/3, okay, well, if I clean that up a little bit, I'm now going to have 8/12 plus 9/12, and I could add those together, and that would be 8 plus 9/12, or 17/12. All right. So if I was solving a really simple equation, that's what I would do. But that idea of multiplying each side by the other's denominator is going to be used on this problem. So kind of stay with me here on this one. All right, so let's write this out. I have 2 over x minus 2. And now what I'm going to do is I'm going to multiply by x minus 5 over itself. Okay, the other person's denominator. Actually, it's plus 5. My bad. And then I'm going to add, and now over here we have 3 over x plus 5, and I need to multiply that side by the x minus 2 piece over itself, which again is 1, so I'm not hurting anybody. And that's supposed to come out to be some number times x plus some other number, which hopefully we'll find, all over x minus 2 times x plus 5, which is perfect. So let's go through and let's clean this up. So on the top, when I multiply this top out, I get 2x plus 10 over x minus 2 times x plus 5. There's no need to multiply that out because all we're interested in are these top values. So plus, and when I do this one, I get 3x minus 6 over x plus 5 times x minus 2 equals, well, when I add the top together, so remember when you add two fractions, the bottom stays the same. So we're looking good down there. Well, let's see what happens with the top. When I do 2x plus 3x, I get 5x. And then when I do this positive 10 added to negative 6, positive 10 to negative 6 is plus 4. So now I think I can see what my r and my t are. My r is 5 and my t is 4. So we needed to know what was r times t. So 5 times 4 is 20. Correct answer, C. All right, number 30, last multiple choice. If ax plus a equals 3, where a is not 0, so a can't be 0, otherwise we'd have 0 equals 3, which is not true, which of the following must be equal to x plus 1. So a strategy on these problems, there's two ways. Either I can try to find x and then once I solve for it, add 1 to it. Or I can try to find an x plus 1 within the equation, which I think is what I'm going to do here. So let me show you what I'm talking about. So if we have ax plus a equals 3, first thing I realize is I can pull out a greatest common factor. I can pull an a out of both of those, factor out an a, and now it's kind of like the reverse distributive property. So a times what will give me ax, and then a times what will give me positive a. So now I'm here, and if you do the distributive property, you get the top answer back. So now I have a times x plus 1 equals 3. Well, I want to find out what's equal to x plus 1. So I'm going to just divide both sides by a, and now I know that x plus 1 equals 3 over a. So my correct answer here is D. All right, number 31, we start the free response. I actually included a little grid here just in case there's any issues on how you grid these bubbles in. But we start off with a radical here. The square root of x plus 4 equals 11. So a couple different ways you could solve this. Just conceptually, ignore the x plus 4 and just ask yourself, the square root of what equals 11? All right, and the square root just means what number times itself comes out to be what's underneath there. So it's kind of saying 11 times itself equals what? Well, I know that the answer is 11 times 11 is 121. So that's a true statement. Square root of 121 is 11. And now you could just try to set up and say, hey, when is x plus 4 going to come out to equal 121? So I minus 4 from both sides, and you get 117. Now, the classical way is to get rid of a radical. So this is the more traditional way. To get rid of a radical, the opposite of taking the square root of something is to square something. But if you square the left, you need to square the right. And this square and this square root cancel each other. They're inverse operations. And so I get to here, same exact setup, finish I should say. So you get an answer of 117. Now when you bubble this, you can either bubble, 1, 1, 7 and do it that way, or you could bubble just the last 3 and do it this way and go 1, 1, 7. The SAT doesn't really care. They will accept either answer. So the correct answer is 117. Number 32, looks like we have a statistics problem here. Box and whisker plots. So if you're unsure about this, you can check out some of my content videos. But you can also just Google box and whisker plot. But let me just kind of break down just the idea of what this means. So when you have some sort of box and whisker, we kind of show you what these represent. So this dot represents the lowest value of a data set. This dot represents the high. So if you subtract those, you could get the range. And then this part of the rectangle is quartile 1, which is basically 25% of the data falls, between here and here. So 25% is in that region. This one is quartile 3, which is the 75% mark. So the top 25% of the data lies here. But the most important part is this line in the middle. Maybe I'll make it in blue. This line in the middle. And this is the median. Okay, this is like the 50% point that half the data lies on one side of the line, half the data lies on the other. So looking up here, it says the box above summarizes the distribution of number of fish caught on 2 commercial boats for the season. By how many fish does the median caught each day exceed the median? So how much more is B than A? So the median for B is at 40, and the median for boat A is at 35. I don't really like that the median line lined up with these lines here, so that kind of bothers me. I wish it was off shifted a little bit because it's kind of hidden. But nevertheless, how much more is it? Well, 40 minus 35, correct answer is 5. So again, you could put a 5 here and bubble it, or you could put a 5 here and bubble it. I'm not sure if you could put it in one of the 2 middle boxes, but I would put it at one of the two ends. All right, number 33, if A is the mean, which the mean, remember, is just the average. So let me get out of there, get my pen going again. So if A is the average and B is the median, which is the middle number, once you line them up from small to big, of 9 consecutive integers. So we need 9 consecutive right next to each other. Integers mean they can be positive or negative, but no fractions. What is the value of absolute value A minus B? So first of all, let's talk about absolute value, which are these bars like this. So absolute value basically just changes any answer to positive. So if I said, hey, what's the absolute value of -7? You would tell me 7. Now, if I said, hey, what's the absolute value of +7? It's also 7. So just whatever's inside those bars, make it positive. So let's kind of get back to the problem. We need 9 consecutive integers. Why don't we just pick these 9? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is the average. So let's find the average of those numbers, which is A. So the average means I got to add them all up. You could just go 1 plus 2 plus 3 plus 4 plus 5, but it might be easier to add them up from the ends, because 9 plus 1 is 10, 20, 30, 45. So they all add up to 45 divided by 9, because that's how you find the average. So it looks like A equals 5. The average of that set is 5. Well, the median, which is the middle number, which they're calling B, the middle number of this data set is 5. So 5 equals B. So when I come back over here and I do this final absolute value, I have the absolute value of A minus B, which, what's the absolute value of 0? Correct answer here is just 0. So again, bubble in one of the sides and you're all set. All right, number 34, looks like we have a quadratic because I see a t squared up there as the biggest exponent. The equation above gives the height of an object above ground, y. So this y represents the height. And t seconds after its launch, so wherever I see the t, those are seconds. So you could make a little t chart if you wanted to. How many seconds after it is launched does the object reach the ground? So 2 ways to do this. If you have a graphing calculator, you have a huge advantage, because if you type in the -16t squared plus 64t plus 80 into your calculator and then go to table, you could pull up an XY table that'll actually just give you all the ordered pairs. And you're looking for when it hits the ground. So the big idea here is when the object reaches the ground, the height would be 0. So basically y equals 0. So if you plug this into your calculator and then you go to table, what you're trying to do is you're trying to figure out what is the x value when y is 0. But we're going to solve it by hand, assuming we don't have a graphing calculator. So graphically, what this looks like is if I plug 0 in for t, so these are my seconds, this is my height, x and y. So if I plug 0 in for t, my y-intercept would be 80. All right. So at t equals 0, I'm at 80. And then it's going to take off from there. And at some point, we're going to hit the ground. And what I'm trying to figure out is what is this t actually right at this spot right there? Like what is that t value equal? So we need to solve this quadratic. So here we go. I'm going to solve it for y equals 0. So I have 0 equals -16t squared plus 64t plus 80. And solving a quadratic, my number one choice always is to factor. You could use the quadratic formula, which we've used earlier in this test. We had to. Or some people like to complete the square. But let's try to factor this. So the first thing is I want to reduce all these numbers by trying to divide And I think I can yank a 16 out of everybody. So if I divide everything by negative 16, all right, so I get 0 equals, I always want to pull out the negative because I want t squared to be positive. So that's kind of a little pro tip right there. So I have t squared, doing reverse distributive property, negative 16 times negative 4t would give me 64t. And then negative 16 times a positive 5 will get me to, or actually take that back, a negative 5. Negative times a negative will get me to positive 80. Now, if I can factor this, which it looks like I'm going to be able to, I need to try to find two numbers that multiply to make negative 5, but two numbers that also add to make negative 4. That's kind of how the game is played. And the two numbers that do that, I think, would be negative 5 and positive 1. They multiply to negative 5 and add to make negative 4. So I do t minus 5, t plus 1. And now I'm going to use what's called the zero product property, ZPP, which basically just says, hey, if something times a number equals 0, either you're 0, that parentheses has to be 0, or this one has to equal 0. And when I solve them both, down here I get t equals 5. Here I get t equals negative 1. If we're talking about seconds, the negative 1 doesn't make sense. The 5 does. So 5 seconds is going to be the correct answer. And if you would have used your graphing calculator, you would have found an ordered pair, 5, 0 there. So correct answer here is 5. Number 35, looks like we have a science problem. Here, I equals V over R. The formula above is Ohm's law for an electric circuit. I is amps. So maybe I'll write over here. So we have amps equal, V is the potential difference. So potential difference in volts over R is the resistance. All right, so hopefully they give us some of these numbers and we're going to solve for something else. A circuit has a resistance of 500. All right, and its potential difference will be generated by 6 n-volt batteries that produce a total potential difference of 6n. So my potential difference is 6n, and the number of amps. The circuit is to have no more than 0.25 amps. So no more than 0.25 amps. So I need to tweak this a little bit. No more than means that this over here needs to be smaller than 0.25. Otherwise, we blow the circuit. So let's solve this. So you solve it just like any other problem that has an equal sign. If you multiply or divide by a negative, you got to flip the sign, but we don't have any negatives. So let's times both sides by 500, and that'll cancel this out, and I'll have 6n less than or equal to 0.25 times 500 a quarter. That is 125. And then divide both sides by 6. And that goes in there. It looks like it's going to be 20 and then 5/6. So the number of batteries will be, it's got to be less than 20 and 5/6, so we can't have 5/6 of a battery. So 20 batteries would be the biggest that we could have. If we go up to 21, we've now exceeded the amps and the circuit will blow. So correct answer here is 20. All right, number 36, in an XY plane, line K intersects the y-axis at 0, -6, passes through the point 2, 2. So let me just kind of do a rough little sketch of this. So kind of have this going on. K intersects the y-axis at 0, -6. So we'll put that down here at -6. Then it goes through the point 2, 2. So right there. So there's our line. So it's going pretty doggone steep. It's going up like that. And then the final question says, if the point 20 comma what lies on that line, what is the value of what? Well, it's going to be way the heck over here. Like if I extend this out, 20 is way over here, and this point is going to be like super high. It's going to go off the paper. So that might not be the best way to do this. The best way might be to write an equation. So I'm going to try to get an equation written in y equals mx plus b form. I know b is the y-intercept, and I know the y-intercept is -6. So I'm going to put that in the b slot. And then I also know, or I can calculate, the slope. So m, or the slope, is basically your rise over your run. So I'm going from -6 all the way up to 2. So I'm rising 8, and then I'm running 2. So a slope of 8 over 2 means I have a slope of 4. So there's a nice little equation that models that line. And now, all I have to, get that back. Now all I have to do is I need to plug in this pair. If you live on the line, then you're a solution. So I'm going to plug in x equals 20, and then I'm going to figure out what that comes out to be. So 4 times 20, take away 6. Well, that's 80, take away 6, gives me an answer of 74. The W kind of throws you off a little bit, but Y and W are basically the same exact thing on this one. So the correct answer is 74. Bubble those in, you're good to go. Now, I've seen some kids just kind of play the game, and they just kind of kept saying, hey, if you're going up 8 over 2, up 8 over 2, and they just kind of had to figure out, if you're going over 2, you're going to have to go over 2 10 times to get you to 20. So if you go over 2 10 times to get to 20, that means you're going to have to go up 8 units 10 times, which would be up 80 units. And since we started from -6, if you go -6 and go up 80 units, some kids did that without ever coming up with an equation. They just kind of kept playing this game until they went over to the right 20 times. So totally up to you. Number 37, in a science classroom where labs are performed, students are seated at lab tables. If a teacher assigns 2 students to each table, 4 additional lab tables will be needed to seat all the kids. If the teacher assigns 4 students to each table, then 4 lab tables will not be used. How many students are in the class? So this kind of sounds like a system of equations because we have 2 different scenarios going on. So let's kind of address the first situation. If the teacher assigns 2 students to each table, so 2 students times each table, so if there are 10 tables, that'd be 20, 15 tables would be 30. 4 additional lab tables will be needed to seat everybody. So we're going to add to that. If we have 4 additional tables at 2 per table, that's going to be 8 more kids. So we have 2 kids for every table, plus 8 more kids when you do the additional 4 tables. So that's under scenario 1. Scenario 2 is if the teacher assigns 4 students to each table. So if I go 4 students times every table, well then 4 tables are not going to be used. So that means we're going to not have 4 tables of 4. We're not going to have 16 kids in that one. So we should be able to set these 2 situations equal to each other. Let's check it out. 2t plus 8 equals 4t minus 16. Subtract the 2t from both sides. And then let's go ahead and add the 16 to both sides. Let's do it all at once. So the t's wipe out. I get 24. I get 2t. Those wipe out. Divide by 2, divide by 2. Now, 12 is not the answer, though, because that means that there were 12 tables. All right? So I now need to take my 12 tables and put it in either one of these. So 2 times 12 is 24 plus 8. That's 30 students. 4 times 12 would be 48. Check that. That'd be 24 plus 8 is 32. I was going to say I should be getting the same number here, hopefully. 4 times 12 is 48 minus 16. Yeah, that's 32. So the correct answer here, how many students? That's our S. The correct answer is 32. Number 38, last problem on this test, says the number y is 20% greater than x. So I'm going to translate that into an equation. So y is 20% greater than x. Well, whatever x is, we need to make it 20% bigger. So 1.20 would be a growth, and I use this kind of situation a lot, where it's 1 plus the percentage when you're growing. And 20%, remember, is 0.20. The number z, so here's my next equation. The number z is 20% less than y. So z is, you take y. Now 20% less would be 1 minus 0.20. All right, or y times 0.80. So now I have a system of equations we need to kind of solve here. So I don't know, so let me just clean this up a little bit. So y equals 1.20x, z equals y times 0.80. I think what I can do here, because what they want finally is the number z is how many times x. So I need to get z and x related, so I need to get y out of there. So I'm going to use substitution. Since I know that y equals this, I can plug it in. So z equals 1.20x times 0.80. And 0.8 times 1.2 is 0.96x. So the number z is how many times x? It is 0.96 or 0.96. I think they'll let you write it either way. So you could go 0.96. So, nope, looks like they just want 0.96. So I don't see a 0 in that first slot. 0.96. Correct answer.